Hello, we are Group 4 for CMSC 206, Database Management Systems, and my name is Paolo Planas. And before we begin, I'd like to introduce my group mates, Ellen Narsha, Ali Chavez, Joel Gano, Flor de Luna Merlan, Johnny Coprada, Robert Romero, Paul Ventor, and Jella Tolentino. So for our topic, we were assigned relational algebra. In this video, I'll be doing an introduction, and in the succeeding videos, my groupmates will present the other information such as operations related to relational algebra. Let's begin. Our objective for this video is to define and discuss relational algebra and to introduce the operations related to relational algebra. We'd also like to talk about what the advantages of studying relational algebra would be. So, one of the main reasons of studying relational algebra would be to know the logic and reason behind relational queries and constraints. So, when you do something, you should always know the reason and logic behind it. Otherwise, what you're doing would be, of course, meaningless. Now, if you know the logic and reason behind these queries and constraints that you're gonna perform later on in your SQL life or database life, you would be best suited to understand these SQL queries because you have the foundational information that relational algebra would provide. Now, the last would be if you have a better understanding of SQL queries that you gain from studying relational algebra, then of course you can use these to optimize your queries and your SQL codes or statements. Just to give a bit of background on how relational algebra was formed, it was all started by a man named Edgar Cod, who used to work for IBM in the 1970s. He did some work on relational algebra and relational DBMS systems, wherein his main work was called the relational model of data for large shared data banks. Now, Edgar Cod was pushing this idea with IBM, but they weren't very fond of it. So, unfortunately, what happened was competitors from Oracle and other companies at that time, I believe it was Oracle, used Edgar Cod's theories and later on formed a query language called SQL. It wasn't like SQL before, but SQL was the predominant or father of the now known structured query language SQL or SQL. Now, since we're talking about relational DBMS, I have a quick question to our viewers. So, what's the difference between a DBMS and relational DBMS? So, the key difference between the RDBMS and DBMS is that RDBMS, or known as Relational Database Management Systems, are applications that store data in tabular form, while you have your DBMS systems, same thing, database management systems, are applications that store data as files. There's a bit more differences between DBMS and RDBMS. I know you guys have went through it, but we have points like for DBMS it's not normalized, RDBMS is more normalized. The support of distributed databases is different between the two, and of course relationship between RDBMS and DBMS is also something that is of significance. Anyway, that's something good to know as we go along. Now, let's talk about algebra. I know you guys went through algebra in high school or college, so everybody's familiar with it. Now, algebra is what consists of atomic operands and set of operators. Now, these form algebraic expressions when operators are applied to operands. I know it sounds fancy, but basically we have our mathematical operations such as addition, subtraction, division, multiplication, which are called operators. And we have our atomic operands such as x, y, 1, 2, 3, 4, 5, 6, and such. I know there's a deeper definition for algebra, but in this video, we'll just trying to look at or take the icing on the cake, as I would say. Now, if we have algebra, what's relational algebra? As written here, relational algebra is a procedural query language. It consists of a set of operations that take one or two as input and produce a new relation as their result. Now, this provides a theoretical foundation for what we know now as relational databases. Below, I have a sample of two tuples. We have tuple R and tuple S. Now, as we said, when we take one or two as input, whether it be from tuple R and tuple S, this produces new relations when combining these two. So in this image, we have an R tuple union with S, and then this is more of a, I would say, a Cartesian product, I would say. But yes, this is a sample of what happens with relational algebra. Now, if we follow the same logic, you would notice that the combination of these tuples would be the same as what we do when we execute SQL queries. So, we can have the select this table and select, let's say it would be like select R table and select S table, and then we can either join them or manipulate them or aggregate or manipulate them as we please. Another insight on how the relational algebra would work is that if in mathematical algebra you have an algebraic expression of like 1 plus 4 multiplied by x plus y, you have x and y as your variables. For relational algebra, however, you have the x and y are your relations. And your operations such as addition or subtraction manipulate x and y to create new relations. So at this point, let's go to operations, and we actually have two types of operations. First would be our unary operations, and second would be your binary operations. For unary operations, let's start with the selection operation. So I have two tables here, and I'll give a brief description of what these operations are. So for selection, we have an operation that works on a single relation R, and this actually defines a relation that contains only the tuples of R. So if your table here is R under selection, that would satisfy the specified condition. So I mean, in plain English, a selection would be selecting. It works off more on a horizontal scale. If you select student ID 1001, then by definition, it would also select first name and last name values such as Juan de la Cruz. So I would say as something to remember by when you go for selection, it's selecting one thing and everything follows. It's always on a horizontal scale. Now the second table below is something for projection. So projection, what do you think? Like you're projecting one thing or two things at the same time. So as you can see, the visual representation is more of a vertical selection type, but this is called projection. So in projection, you can work on a single relation, and then this would define a relation that consists of a vertical subject in the table. Now, if you extract the values of the specified attributes and you eliminate duplicates, that's also something that projection would do. So in this sample, you can select student ID and last name, and then from there you can treat it however you like. I think the most important thing to remember with unary operations is that you are always operating on one relation. If unary operations deal with one relation, now for binary operations, it is more on the operation on multiple pairs or a pair of relations. So the first binary operation would be union. So union, keyword, joining together, right? So our first union would be more on um, having, for example, this first table on top and second table below, and then you unionize or bring together the relations of the first and second table. Information can be from both table or duplicates from each table, but the most important thing for union is that both of your tables must be union compatible. And also, I would like to add for union, uh, both the first and second table must be or must have the same number of attributes. And last but not the least is that union is symbolized by, of course, the letter U, uh, which would combine these two tables in the example. Now the next one would be set difference. Set difference, as it says, is like most likely, I would say, an idea of it is like subtraction because you're setting the difference. So in this operation, you're actually trying to find tuples in one relation but not in the other. So you can say find the courses, CMSC 204, but not students who have first name Juan. That would be an example of a set difference. The same with union. Set difference must be union compatible when you're doing the operation. For intersection, it's more like combining two relations or tuples. So, for example, if we have on our first table student ID 1001 Juan de la Cruz, we'll be combining this with the course and grades 1002 CMSC 20480. Same as union and set difference, intersections must be union compatible. And the last binary operation we have would be the Cartesian product. So Cartesian product, in summary, allows combining information from two relations. So for example, we can have the combination of student ID and from table 1 and then the grade column from table 2. So Cartesian product, it's basically an operation that defines a relation that gets concatenated for every tuple of a relation of each table. I know it sounds kind of a word like a word tongue twister. I mean, but if you would think of it, it would be most likely be something of a multiplication operation. So if you have for example, student ID and the grade, so you will have a new table for the Cartesian product having 1001, 95, 1001, 80, 1001, 85, and so on. There's other examples of Cartesian products and sub-operations of it, which we'll be discussing further as we go along. So that's the introduction to relational algebra. I hope it's been informative for you. If you have any questions, feel free to ask, and uh, let's proceed to the next video.